This is a particle podcast. WA Science told different. Powered by Scitech.
Please Look Up is recorded at Scitech on Whadjuk Noongar land. Good evening, everybody, and welcome to Please Look Up, a monthly podcast where we take you through a guided tour of the night sky as seen from Perth, as well as taking a deep dive into some of the more out-of-this-world space news. This episode is about what's in the night sky in the month of March. My name is Leon, and firstly, I know it's a bit late, but Happy New Year! I hope you've enjoyed gazing into the clear summer night skies without us, as we've taken a bit of a break here. And we're back with a bit of a new format this month. First, you'll hear about what's in the sky, almost as usual, and then we're rolling out some new segments to share more of what's going on in space. But before any of that, let's welcome this month's co-host, Beth, a professional presenter from the Scitech Planetarium. Beth, thanks for being here.
Thanks, Leon, for having me. I'm especially excited because this month we're turning the tables, isn't that right?
Oh, yes, I guess so.
So since Leon is actually the biggest space nerd among us all, this time I get to ask the questions. So, Leon, what's going on in the night sky this month?
Fire away, hey? Well, I guess we'll start in the morning sky because I had the mispleasure of being awake at about 5 o'clock in the morning the other day.
No.
I'm definitely not a morning person. And I did catch a glimpse of Venus up in the eastern sky just before sunrise. It's been there for about 7 months now, and this is the last month you'll actually get a chance to see it in the sky before sunrise. It's getting lower and lower in the sky each day. So if you're up at 5 o'clock each day, you'll see it getting lower and lower and lower. And by the end of the month, it'll actually be gone behind the sun. So this is basically your last chance to get a glimpse of Venus in the morning sky, if you're a morning person.
So wake up early to catch the morning star.
Yes, that's right, as it is sometimes nicknamed. Of course, you know as well as I do that it's not a star.
No, it's a planet, and also called the evening star.
When it appears in the evening. Which it will.
The worst possible name for something.
Yes, about 2 months from now, maybe 3, it'll be up in the evening sky, and it will be the evening star for the next 9 months or something like that. You can also, they're not very good, if I'm being honest, but Mars and Saturn are also there in the morning sky as well, but they're very, very faint. They're very hard to see. You're probably better off waiting another month for them to come out in the morning. So instead, let's go to the evening. Northwest. Do you remember what planet's up there in the northwest during the evening?
Northwest is going to be Jupiter, I think.
It is.
And if you have the eyes of a telescope, I think Uranus.
Yes, that's right. Uranus is not far from Jupiter. You will need an app if you want to try and find that. I use Stellarium myself. But yeah, Jupiter, you don't need a telescope. And it looks kind of yellowish compared to the stars. Most of the stars look whitish. I know there are colours out there, but most of the stars look whitish, whereas Jupiter does really just look kind of yellow at the moment.
Is that just because of the makeup, the gas in its atmosphere?
A little bit, and a bit of the viewing angle, and maybe just the time of night as well. A little bit of everything, really. And I'm talking about compared to the stars. It still looks quite white, but it's a noticeably different colour, and it is very bright. But a bit like Venus, Jupiter is getting lower to the horizon as well. So if you go out at the same time every night, maybe 8 o'clock, you'll see it getting lower and lower and lower throughout the month. And by the end of the month, again, it'll be gone. Like, if I'm being honest, the planets aren't trying very hard this month. They're all near the horizon, and they're all very faint. Mercury, you'll barely even get a chance to see in the later half of the month, just after sunset, but it's almost not worth looking.
Now, there's something that I wanted to ask about planets and stars, because people ask a lot, and people sort of say a lot, like it's common knowledge that you can tell the difference between stars and planets because stars twinkle and planets don't. But as far as I'm aware, that's not strictly true.
No. Planets do twinkle as well. It's just that as a percentage of their brightness, a twinkle is significantly less. So imagine you've got, you're getting 10 units of light per second from a star, and the atmosphere distorts 5 of those per second. So the brightness might fluctuate by about 50%. Whereas for a planet, because they're so much closer to us, even though they are not shining themselves, they are only reflecting sunlight, you might be getting 100,000 units of light per second. And if 10 of those flicker per second, that's only a tiny little fraction.
Right.
So there is flickering and there is twinkling, but it's just so much less as a percentage of their brightness that it doesn't really look like it. But on really, really windy nights, turbulent nights, you'll definitely see planets twinkle, especially if they're particularly small, like Mercury, or far away, like if Mars is on the other side of the sun, like it is right now. You will definitely see a planet twinkle. It's just much less obvious than a star.
Right. So telling the difference between stars and planets in the night sky, planets are probably going to be some of the brightest, and they might be slightly less twinkly.
Yeah, more or less, except for Uranus and Neptune, but we won't worry about those.
Don't worry about those.
But yeah,
Not
that's
those
right.
two.
If you look at Jupiter in the northwest during this month in the evening sky, take a look at it and then take a look at a star and you'll see the difference. But also if you look at it long enough, you'll see some scintillation, as is the fancy word. But yeah, it is a lot less.
Awesome. Thanks for clarifying that, Leon.
A pleasure. I often like to tell people that's not the best. The best way is to point a telescope at it. And if it turns into a disk, it's a planet. If it stays as a point, even through the most powerful telescopes, stars are just infinitesimal points. They're just so far away. Except
for the sun, which you should not look at through a telescope.
Correct.
Unless you have a very special telescope.
That's right. Even with your eyes, you shouldn't look at it.
No.
So that's what's in the planets are concerned. A couple of other interesting things. Of course, we have, even though it's according to our normal calendar, the season of autumn has begun. In the lunar calendar, it's still the season of Bunuru, the second summer, and you don't need to go outside to find that summer. It really is still going.
It's still quite warm.
Yes, but we just have the equinox on the 20th of March, which is when the sun passes directly over the equator, and that means roughly there's going to be 12 hours of day and 12 hours of night, no matter where you are on Earth. There are minor variations, but that's what it means, equinox, equal night. So that's where the word comes from. And if you live on the equator, 0 degrees latitude and longitude, you'll see the sun... 0 degrees latitude, you'll see the sun pass directly over your head at midday on the 20th of March, which is, kind of neat.
It is neat. I mean, if anyone does live on the equator, go for it.
Yeah, exactly. But my personal favourite thing this month is International Pi Day, 14th of March.
Oh, of course, 3.14.
Yes.
International Pi Day if you're American.
Yes, if you use freedom units, it's 3/14. So yeah, well worth it. Get a tattoo or something like that.
Yeah. Do you have a Pi Day tattoo, Leon?
I might not.
Oh. Well, that's a mystery.
How many digits of pi do you know?
Oh, goodness. 3.1415926.8?
265358979. That's all I know.
Told you, Leon's the biggest space nerd. And pi nerd, apparently.
So that's the exciting news for the night sky this month.
I'm looking forward to going out and seeing some stars. But now it's time for us to introduce some new segments.
A new segment, yes.
I know. So our first new segment today is going to be something we're going to call Space Flight Focus. And in this segment, we're going to have updates on space flight. So it might be a variety of different things. But this month in particular, we're going to focus on attempts to reach the moon. So, Leon, I'm going to ask you what happened. And then when there's new updates in the future, we can bring it back, because I'm sure there will be new successes and new complete and utter failures in human endeavours into space. So this year, so far, we've seen 3 attempts for the moon with varying levels of success. So first up, there was NASA's Astrobotic Peregrine lander. It's an unmanned vessel carrying a bunch of small rovers and other equipment from NASA and Mexico. It launched successfully on January the 8th. The spacecraft reached the moon, but it missed.
Yeah, some things went wrong. Yeah, so Astrobotic is a company that built the lander.
I thought it was a new word for space robots that I didn't know before.
No, so it's part of something called the Commercial Lunar Services, Commercial Lunar Payload Services, or CLPS if you prefer. It comes out of the fact that NASA spaceships can't fail, because if NASA puts a spaceship on the pad and it blows up, that's taxpayer money literally going up in flames. So what they do is they pay other companies to build the spaceships for them and send them to the moon. And Astrobotic is a company that's done that. It launched successfully, and in fact, the launch was itself really interesting. It was the first launch of a new rocket as well, called the Vulcan Centaur, by a company called United Launch Alliance. They're basically the main competitor to SpaceX in the United States.
Oh, wow.
They've developed, as rockets technology is getting better and better, ULA have developed this new rocket called the Vulcan Centaur. It's taken them quite a long time, and this was the first test flight of it, and it worked perfectly. It flew really well. It got the spacecraft into orbit, the Peregrine spacecraft into orbit, on its way to the moon, and after that, once the Peregrine spacecraft separated, it is in charge of its trajectory on the way to the moon.
Yeah, well, because isn't normally the rocket launch the part where it's most likely to go wrong? Like, a mission is most likely to go wrong on the launch pad, right?
Yes, yeah, that is statistically the most dangerous and most likely to go wrong.
So the fact it got past that, everyone's really excited. Peregrine is through atmosphere, in space, heading for
the moon. Yes,
nearly.
It's on a moon. It's on a lunar trajectory, but it then needs to take over when it gets to the moon and put itself into orbit and so on. So as far as the rocket is concerned, everyone's very happy with the rocket. But then not long after the launch, the lander started showing a leak of fuel, a fuel leak. And that fuel leak, it was hissing out fuel overboard, and that was pushing the spacecraft off course. And so to counteract that fuel leak, they had to, of course, fire the engines, which uses more fuel, and so it was just running out of fuel. And eventually they deduced it was going to be impossible for it to have enough fuel to reach the moon, land safely, and deliver the payloads to the surface of the moon.
So did we just send it off into space?
No, they turned on the science equipment. They got as much data as they could. There were some things, measuring particles in space and magnetic fields and things like that.
Okay, so not a complete bust.
Not a complete bust, but these experiments were designed to be done on the surface of the moon, and they never got there. They got the spacecraft just on its orbit. It got all the way out to where the moon was, and that was where it was supposed to then take over and then go into orbit and then land. But they made the decision, no, let's let it reach its furthest point, it's called as apogee, and then come all the way back down, and then it burnt up in Earth's atmosphere off the east coast of Australia, actually. So it wasn't a great success, but they were very open with what they were trying to do and the problem solving they were trying to do. But once you've got a busted engine, you kind of got no choice.
Yeah, so they made the most of a bad situation. We got some good data, and everyone's big thumbs up for the rocket.
Yep.
But we might need to try again with the spacecraft.
Yeah, they think it was a valve that got stuck. So, when you want to turn the engine on, you need to open the valve to let the fuel go in. Yeah. And the valve got stuck open, and so it just kept venting fuel, and they couldn't close it. It's not the first time a sticky valve has caused the end or the change of a mission profile. So
yeah, fair enough. So we need NASA, or not NASA, because NASA is taxpayers. So we need Astrobotics to work on their valves.
Yes, that's it.
Awesome. So next we had an attempt from JAXA, which I think might win coolest space agency name. They're the Japan Aerospace Exploration Agency.
Yes.
I just think that, anything with an X in it sounds pretty cool. But I don't know, SpaceX feels like it knows that it's got an X in it.
Yeah.
I don't. Maybe that doesn't make sense. But their lander was called SLIM, which is Smart Lander for Investigating Moon.
Yes.
And that actually launched in December, but it only arrived on January the 19th.
Yes, actually launched in September. September last year.
I thought it only took 3 days to reach the moon. Like, in general, it takes 3 days to reach the moon. Why did this lander take so long to get there?
The Apollo missions took about a 3-day trajectory back in the day. No, this one took much longer because it took a very, very fuel-efficient trajectory that utilises Lagrange points between the Earth and the moon, which are those gravitational stable points. They are basically shortcuts that use less fuel, but they take a long time. And, they're very, very complex orbits that people much smarter than me figure out. Okay,
cool. That was, I was just curious. But sometimes the more fuel-efficient route takes you longer to get there.
Yeah, it means your spacecraft is not as heavy, and if your spacecraft is not as heavy, it's a lot cheaper. Mass is the enemy in space.
Yeah, absolutely, because you just need more fuel to get the rocket
up.
And
you need more fuel to get that fuel off the ground, and it's an exponential equation.
So this spacecraft from JAXA landed on the moon.
Yes.
So we're a step ahead of NASA, but it landed on its side.
Its side, yeah.
And then also fell over.
Yeah, it was intended to land on its side.
Oh, okay.
However, it did land on its side and then continued rolling over and then fell onto its top. So it landed on the side, the wrong side.
Right, okay. And that meant that its beautiful array of solar power panels to keep it nice and powered on the moon were not facing the sun.
Yes, that's right. So, it was intended to land, we say side, let's imagine belly. So it's got engines on its bottom side, and then right at the last minute it would tip over and land on its belly, and then the solar panels on its back would be facing straight up, and then it would get sunlight. And instead it kept rolling and landed all the way on its roof, and that pointed the solar panels away from the sun for a while. However, after a few days on the moon had moved around far enough that the sun angle was able to actually incident onto the solar panels.
Okay, so we still had some solar power there.
And it got back to life. And it came back to life. And interestingly, before it landed, it did have 2 tiny, tiny little rovers on board, and it ejected those just before it landed, and they were able to actually image. They worked fine, and they were able to actually take a photo of the SLIM lander. And you've seen like the picture of someone with their head stuck in the sand and their legs are flailing in the air. That's basically what it looks like. It's got the engine sticking up into the air, the nose is rammed into the ground on the moon.
Oh, no.
It's a beautiful picture, though. And they landed it, and it's called a soft landing. When something crashes into the moon, they call it a hard landing.
Okay.
Yeah, rapid unscheduled disassembly. Whereas this one, it was a soft landing. It's still in one piece, and it still worked. They can talk to it.
Just only at certain times,
yes,
rather than
right.
always.
But interestingly, after a few days, the sun obviously moved out of sight again, and then it went into the lunar night. The lunar night takes 2 weeks, and it gets down really, really cold, like minus 150 degrees. They weren't even sure if the rover was going to survive. The lander. They put it into sleep mode, and then 2 weeks later, when the sun came out again, it came back to life, which is something it wasn't necessarily designed for. They weren't sure if that was going to happen, but it was working.
So is this a success or a failure?
Huge success, yeah. The actual only goal of this mission was to prove that a robotic spacecraft could autonomously land within 100 metres of its target. So they gave it a target. They said, land there. And then after that, there was no human control.
Oh, wow.
And as this thing is coming down and getting higher and higher resolution images of the terrain lands. The train changes and there's a big boulder there. We can't land there anymore. The computer has to make onboard decisions because there's a time delay before you can send human signals there.
Right.
So it has to be autonomously controlled. And that's one of the reasons why it's so hard landing on the moon, or heaven forbid missions landing on Mars, for example.
Well, I was going to say, is this testing on the moon sort of a precursor to unmanned Mars missions? Because obviously the moon is closer, so it's cheaper to get a robot to the moon than to Mars. But if we can sort of proof of concept that technology with the moon, then I guess we can take it to Mars quite easily.
100%. And there obviously have been landers that have landed on Mars as well.
Yeah.
But same again. If you think about 20, 30 years from now, there will be in some people's imaginations dozens of moon missions monthly, and most of those would be if you're landing supplies and gear and habitats, that's all going to be robotic. And if you need to precision land those, this is 100% a proof of concept of that you can do it to great accuracy.
Yeah.
That it was a huge success. I think JAXA gave themselves a 6.5 out of 10 for their landing.
I'm going to give them an 8.
Yeah, it's not bad, is it?
Yeah, it's not bad.
Yeah.
And also if it's cute.
Yeah.
Like if they've got some cute little photos of a lander sort of with waving its legs in the air, then I think that's bonus points for style, to be honest.
Well, I encourage anybody listening to Google slim moonlander, and you'll get a picture. You'll see it sticking in the air. And then I encourage you to also Google Kerbal Space Program loading screen. You can see the picture there.
Yes, absolutely.
And that's a cartoon, and let me show you the real picture.
Oh my goodness, yeah. No, those are the same thing.
Yeah, so I
Life imitates art.
Yes, it does.
Okay, so our final update is the Intuitive Machines Odysseus lander. So this is part of the CLPS program. Now, space loves acronyms. What on earth is the CLPS?
That was what I mentioned earlier. That's the Commercial Lunar Payload Services. So
Right.
it was another NASA contract.
Okay, cool.
This time to a different company called Intuitive Machines.
Yes. So previously we had Astrobotics.
Yes.
And this one is Intuitive Machines.
Yep.
So they launched on the 15th of February, trying to land on February the 22nd. But this one also fell over?
Yes, that's right.
Why do these lunar landers keep falling over? Why can they not stand up, Leon?
Yeah, this one is a little bit still under investigation, obviously. What we do know is that one of the legs broke when it landed. It had 4 landing legs and one of them broke and it tipped over. So by all accounts, it probably landed upright, but might have landed a bit hard. Maybe it lost control at the very last second, or maybe it landed safely, but the launch had shaken something loose or something like that. And one of the legs broke.
So is that a soft landing? Or
that's also a soft landing. Yeah, it touched down.
Feels more like a medium landing, I think.
Yeah, it could be. But it didn't explode on impact. They were able to communicate with it, but its antenna was kind of pointing in not quite at Earth, so they had to use the Parkes radio telescope in Australia, the dish.
Oh, the dish.
Yeah, they had to use that. It's the biggest dish that they could use to point at the moon at the time, and they were able to get communication from it.
Oh, good.
And yeah, it was really quite interesting that in the approach to landing, the lasers that they were going to use to measure the distance to the moon, they found that they had not turned them on properly. So they actually had to use some secondary onboard lasers that were designed for a completely different experiment and interface them into the computer's landing system to actually land.
That's so amazing, though, that ability to, one, know that you've got these backups, that you can do that and you can problem solve with that when you've got just unmanned missions, because obviously if you've got manned missions going like to Mars or something, knowing that you can use that human innovation, because I guess that's also the difference between the fully autonomous robots that we were talking about with the JAXA mission. Like that JAXA robot wouldn't have been able to think to itself,
that,
I'm going to use these secondary lasers.
Yes.
So I think it's really cool that they did that.
A room full of people are still able to problem solve like that.
Yeah. And, being able to think that laterally, like, oh, wait, no, we have other lasers, so surely they can do the same thing.
Yeah.
Oh, that's so awesome.
Yeah, interface with them. So, yeah, that's 2 out of 3 of those missions I would call a pretty good success. Two soft landings, 1 burnt up in the atmosphere.
Yeah, I think 2 out of 3.
Yeah, and I think a great poet once said that ain't bad, is it?
Leon, it's going way over my head.
Okay, you'll have to look that up later.
Oh, no.
Yeah, I do this for the people.
Oh, no. I've got to bring some obscure references next time. Mm-hmm. They will all be T.S. Eliot. Wait, no. I could find some astrology references just to make you really happy, Leon. It's because Mercury's in retrograde. I'm not understanding your joke.
I hate being a full moon aquarium.
Okay, so we have another segment. So this time we are presenting the very radio-friendly Space Picture of the Month.
Yes, I realise this is a medium that doesn't necessarily translate well to podcasts, so we're going to do our best to describe it. I brought a picture to show you, you've brought a picture to show me.
Yeah.
We're going to describe them and talk about them. We'll be popping these images in the show notes and also on Instagram. If you want to check these out, you can look at those and listen along with us as we try and describe these pictures to you and to each other and try to make sense of them all.
And you can find our Instagram at ParticleWA for those pictures. Okay, so I'm going to have a look at it now. So it's from space, looking back onto planet Earth. I can't see any land masses on planet Earth, I don't think. I can see a few lovely big white fluffy patchy clouds, but no land masses, which makes me think that we're probably over the Pacific. And then in the foreground, it almost looks like a robot wearing a mask. Such a weird description. This is so hard. But there's also like a little arm coming out of it, which says Pocari Sweat, which is an amazing Japanese not energy drink exactly. It's like a what are they called?
Electrolyte beverage.
Electrolyte soda, yeah. So I'm imagining, and there's lots of reflective surfaces as well. So I don't know, we must be looking back from some sort of, I would assume, Japanese space mission.
You would think so, but no, you're close though.
Oh.
This is this is a photo taken from a camera on board the Astrobotic Peregrine lander that we spoke about earlier.
Not the Japanese one.
No, so it's on its way to the moon.
Pocari Sweat, why?
We'll get to that, and that's why I picked it. Yes, this is this is the first lunar lander we spoke about, the one that ended up not getting to the moon. It burnt up in Earth's atmosphere, but this is not long after it separated from the rocket, and it's on its way to the moon. And yeah, this is a onboard camera looking down, so it's at the top of the lander and it's looking down. So that little thing sticking out to the side is one of the landing legs, and then in the middle there is this Pocari Sweat, and I was so confused why is there a can of Pocari Sweat on board? So yes, Pocari Sweat it's a drink. Why is there a can on board? And the company, I looked this up, they said they wanted to be the first company to put an advertised product on the moon, and they provided money to the Astrobotic company to provide them, to help them launch and things like that. And as part of that, they wanted to put a can of their drink on board. Now, it is an imitation. It's not filled with an actual drink. It's
what's the point then? What if
it's still got their logo on it? And here we are talking about it.
Some moon aliens that want a little drink.
Because of course, by the time you put that in space, it's liquid. It will freeze and rupture, and then that could damage the craft. No, so it's filled with an effective mass of sand or something like that to simulate the weight of the actual beverage. But yes, there it is on board, and you know what? It burnt up in the atmosphere. They never got to land on the moon.
No, but also kind of yay. Yeah. Because the thought of adverts on the moon is terrifying.
Yeah, it's the first attempt of many, I have no doubt.
No, I'm sure.
It's a grim future, perhaps.
Okie dokie. So I think I was fairly close. And And I think I've picked a picture that is possibly even harder to describe than a space robot wearing a mask.
Oh my gosh. Okay, I know what this is because I've looked at this particular thing many, many times.
Because it's gorgeous.
But trying to describe it is very, very hard. It's called the Crab Nebula. And what it looks like is, imagine a water balloon, imagine poking it with a pin and then taking a photograph of it as it's exploding.
That's a really, really good description.
Thank you. Yeah, and you've got these weird tendrils and filaments, and everything looks like it's moving, but it's a still photograph. But that's because in real life everything is moving. And there's like an orange overlay, but then sort of closer towards the center. So it's roughly oval shaped, but it's like hairy, for lack of a better word. And the outer edges are all kind of orangey, and then in the middle towards the center it's much bluer. What's going on in this photo, Beth?
Well, so this is the Crab Nebula, as you said. So you said it's roughly oval-shaped. I think that they would really love you to describe it as the shape of a crab's carapace without any legs.
Yeah, I think the reason it's called the Crab Nebula is the first person who ever saw it, this is back in like 1860 or something, they didn't have photos, so they would draw it, and the first person to ever see it couldn't draw for shit. So he drew something that looked like a crab.
That's fair. I mean, so I picked this particular image of the Crab Nebula because it's the James Webb Space Telescope image.
Oh,
so
that I did not know.
There was a Hubble image of the Crab Nebula, but this is the James Webb Space Telescope image. So it's in higher resolution than we've previously been able to see the Crab Nebula. And I love the Crab Nebula because we, as humanity, witnessed the supernova that caused it. And so that's because we can't take pictures of supernovas because there aren't, we can, but there aren't any actively happening right now that we can see.
Not in our galaxy anyway.
Yeah, exactly. So the Crab Nebula, it was caused by a supernova that Chinese astronomers wrote that this supernova, when it happened, it was bright enough that you could read a book outside at night because of the light of this supernova.
Wow.
And we think that the next star that might go supernova, everyone's keeping an eye on Betelgeuse, which is Orion's red shoulder. So that is why I picked this image. But I wondered if you actually knew even more about the Crab Nebula, because one of those things about nebulae is the images that we see of them, a lot of the time they are these beautiful, colourful images of space, and that makes people really excited about them. And those are lies, are they not?
I don't like the word lies, but they're visual communication that is not necessarily obvious right at the front. So yeah, the Crab Nebula, if I remember, supernova, by the way, is an exploding star.
Yes,
we should clarify that. Not every star explodes, but some of them do. And yeah, Betelgeuse is probably the next one that's going to go, in about 1 million years, I think. So, couple of not long as far as the universe is concerned. It's in the northwest sky tonight, not far from Jupiter. They're false colour images. So you said this image is from the James Webb Space Telescope. The James Webb Space Telescope sees infrared, which is heat. Our eyes can't see heat. But if you've ever looked at an infrared camera, you're getting the same image. But that infrared camera is adding those colours in so that you can see it.
Right.
And same with what we're seeing here. So the James Webb Space Telescope collects that infrared light. And again, it's invisible to the human eye. So software is used to add colours in so that the human eye can then understand what's going on.
Yeah.
So yeah, lies is not the it's a provocative term. But yeah, it's so that we can see it.
So if you were closer to the Crab Nebula or any nebula, would you be able to see it? Or is it just because we're so far away from it that we have to use infrared to see it, I guess is what I'm saying.
Bit of both. The infrared, doesn't matter where you are, you won't see it.
Yes.
As a human being.
Yeah.
But if you're closer to it, there are probably more details you'll be able to pick up. Some of it probably is better able to be seen in visible light, but you just have to be much closer to it. So some of the gases, if they're glowing, if they're hot enough, for example.
Yeah.
Right at the core of the Crab Nebula is a spinning neutron star, a pulsar, which is white hot. So,
Yeah.
you would see a little tiny white star at the middle there. So, yes, you could see things if you were closer, but you still wouldn't see the infrared that's been given off there. You do need the right equipment to see it.
Yeah. Awesome. Thank you so much, Leon.
Great picture. Good choice.
Thank you.
And, if you're ever going to draw, learn to draw properly before you draw a crab, because you'll see we're going to post these pictures alongside the podcast.
Yeah,
and
absolutely.
It looks nothing like a crab.
It doesn't look like a crab. I had so many nebulae that do actually look kind of like what they said,
Yeah.
so I deliberately picked one that's a little bit difficult. I thought I'd give you a challenge this time, Leon.
I said that this looks like a still picture. It is expanding, and we can measure how fast it's expanding, and then you can work back and say, well, if it's expanding outwards at this speed, let's just wind the clock backwards and it moves in at that speed.
Oh my goodness, that's
How
so
long ago
awesome.
would we have to go for it to all be in the same spot? And you get back to about about the 11th century, about the year 1050.
Yeah.
Match that to 1054. There you go.
And match it to the records of Chinese astronomers saying,
Yes.
like, we've seen this very, very bright light in the sky at night.
Yeah.
That's incredible.
Amazing.
Oh, science is so cool.
It is.
Okay, so now away from our radio-based image segment, something slightly more suited, we have our constellation of the month.
Yes. For this month, I've picked the constellation of Carina.
Ooh, that's a tricky one, because that's actually one of a set.
It is part of a set. Yes, you know about this. You can tell me about the Carina constellation, Beth.
Well, Carina is, I think it is the bow of a ship, which comes in three parts. So there's Carina, which is the bow. There's Puppis, which is the poop deck, or it's the stern, is the rear of the ship. And then there's Vela, which is the sail of the ship. And the whole ship together makes up the Argo Navis trio, the Argo being the ship of Jason and the Argonauts. And those are the Greek legendary adventurers that went on the whole Golden Fleece thing.
Yes, absolutely right. So yeah, Argo Navis used to be one giant constellation, but yeah, it was broken up into those three that you said, Carina, Puppis and Vela.
To make it more manageable, or just...
Yeah, I guess so. Just to make mapping the sky a bit more uniform, because you would otherwise have this one huge constellation and then all the other ones being a bit more modest in size.
Yeah, that's fair. I guess also because the way that it's the International Astronomy... What's the organisation called?
International Astronomical Union.
Yeah, so the international... That's really difficult to say. The International Astronomical Union divides the sky up by constellations, and it's how we find it easy to map, like, oh, if you're looking for this nebula, it's in this constellation. And it's not like, if I said this, like, the Orion Nebula is in Orion, I wouldn't necessarily mean it's inside the outline, although that one is. But yeah, so I guess if you had this massive constellation, it's like, oh, it's over there somewhere in that entire quarter of the sky.
Yeah.
Would make it a little bit trickier.
That's right. It's a bit like dividing a country up into regions and territories and states. If I say we're in Australia, sure, it's like saying the Orion Nebula is up in the sky. But if I say we're in West Perth right now, that narrows it down a lot.
Yeah, absolutely.
And so, Carina is a constellation. If you want to look at it, it's in the southwest sky during this month, and it's the best way to look at it is to look for the second brightest star in the whole night sky. So you might know, of course, that the brightest star in the night sky is... Sirius, that's right.
Which you can find using Orion's belt.
That's right. It's not far from Orion. In fact, it's all over in the western sky tonight.
So I imagine that if you're looking for Carina in the night sky, if you can find Orion in the northwest,
yes,
and then you can find the Southern Cross in the south.
Yep.
So if you found those two, look somewhere in between them.
Somewhere in between.
And that's a good space to start finding Carina and to start finding this second brightest star.
Yeah, that's right. And you'll see there's Sirius, the brightest star, which is close-ish to Orion, and then a little bit closer to the Southern Cross, you'll find the second brightest star in the night sky, which is called Canopus, and that marks part of the Carina constellation.
So the name Canopus, because it sounds most familiar to me in my mythology nerd brain to canopic jars, like the Egyptian burial jars?
I don't think so. From what I have understood, I think it was named after a Greek character called Canopus, who was I think he appears in the Iliad as the servant or he was the shipmaster of a ship that one of the kings of Greek sailed on.
Was he the shipmaster of the Argo?
No.
Why?
I might be wrong here, but I seem to remember him being a servant to Menelaus, who was one of the commanders of the Greek armies in the Iliad.
Well, it wasn't Menelaus the king whose wife got stolen and started the whole thing?
Might have been.
Yeah, I feel like Menelaus was husband of Helen.
Yes.
Yeah.
Yeah, you're right.
Yeah. I don't know why they've put him on the other boat. They've put him on the wrong boat.
Yeah, there you go. But anyway, that's where Canopus comes from. And then the rest of the constellation sort of wraps around to the left. And you can make the false cross, if you've heard of the false cross.
Yeah.
It's not in itself an actual constellation. It's part of Carina, the constellation.
Oh, okay.
So the Southern Cross is a real constellation. The false cross is not. It's actually just a pattern within Carina.
Oh, okay.
But yeah, you're best using an app like Stellarium or Sky Safari to help you really get the hang of Carina. The reason I've chosen Carina as the constellation of the month is Canopus. Well, you can tell me, what's the most awesome movie in the cinemas right now?
Dune 2?
Dune Part 2. Do you know which star Dune orbits?
In theory.
Yes, it's a fictional planet. It's not real, obviously.
Yeah. Just checking. Canopus?
It orbits Canopus.
Oh my goodness, how did I guess that?
The clues were subtle, but they were there. So yeah, within the canon of Dune, of which I am a huge fan, Dune is the third planet that orbits Canopus. Now, in real life, we haven't found any evidence for any planets around Canopus. We don't know. Canopus is itself a very, very hot star. It's about 7,500 degrees, so about 1,000 degrees hotter than the sun, and it's about 10,000 times brighter than the sun.
Oh, wow.
So it's a very, very hot, very, very bright star. The only reason it's the second brightest star in the sky is that it's so far away from us. Sirius is much, much, much closer to us, which is why it looks brighter. But in terms of that absolute brightness, Canopus is significantly brighter, and therefore it's no surprise that it might be the location of a huge desert planet that's almost inhospitable to all life.
Yeah, absolutely. So if we were stood on the surface of Dune, which, knowing science and knowing science fiction, if we do find a planet orbiting Canopus, we will probably call it Dune.
Yeah, if it's not called Arrakis or Dune, I don't know what we're doing here.
What are they doing?
Yeah.
So if we were stood on Arrakis, if we were stood on this planet orbiting Canopus, would we be able to see our sun?
Excellent question. No, I don't think you would, because it's about 320 light years away, and I think from that far away, our sun is just not bright enough.
Yeah.
It's the other way around. Canopus is bright enough to be seen from here.
Yes.
But I don't think the sun is bright enough to be seen from there. I'm not 100% certain about that, but I think you're right.
Well, I mean, I'm throwing theoretical questions about theoretical planets at you. So, but yeah, I always find it interesting when we're talking about other really bright stars, because we can see them from here because they're so bright. But some of them are incredibly far away from us.
Yes.
So
we're talking, of course, without a telescope. With a telescope, you could.
Yes.
With the naked eye, I'm not sure you could.
No. Oh,
that's an excellent question.
No worries. So is there anything else about the constellation or about Canopus that people should think about as they're looking up into the night sky?
Yeah, there is. You mentioned the Orion Nebula before. There is, in fact, the Carina Nebula, which is significantly larger than the Orion Nebula.
Oh, wow.
But like the Orion Nebula, it is a place of star formation. There are new stars being born there. And one of the very first pictures from the James Webb Space Telescope was of the Carina Nebula. There's like the cliffs of the Carina Nebula, it's called, or something like that. And yes, worth looking out for. The only reason it's not as well known as the Orion Nebula is because the history of astronomy is dominated by Northern Hemisphere astronomy, and it's not very easy to see from the Northern Hemisphere. But it is actually much more interesting, much larger. There's a lot more going on in the Carina Nebula than there is in the Orion Nebula. They're both fascinating, of course, but the Carina Nebula, or the Greater Carina Nebula as it's called, is definitely something worth looking up. If you have a telescope, point it at it, or if you just want to learn about it, Google it.
I would say that for, to be honest, any nebulae, they're nice to look at. Absolutely go and have a look at some images.
Remember, those colours are usually added in by the astronomers wanting to illustrate certain details.
Yeah. Amazing.
And that's all I've got for Carina. That's it for this episode of Please Look Up. Thanks for being here today, Beth. It's been an absolute pleasure.
No, thank you for having me. I've had a great time.
Thanks for listening. If you have a space question, get in touch with us. We might be able to answer it in an upcoming episode. Visit Particle on Instagram @ParticleWA and send us a message. We'd love to hear from you. We'll see you next month. If you want to hear more interesting space news, check out the website particle.scitech.org.au for more information.